All right, it's 10 a.m. We'll go ahead and get started. Welcome to week 3 of Advanced Kentucky's AP Statistics Content Review Sessions online. My name is Aaron Timmons. I'm the Mathematics Content Director for Advanced Kentucky. I'm joined today by Dr. Sherry McGuffin, who is our STEM coordinator, and our presenter today, we're very lucky to have Mr. Adam Shrager with us to talk about inference for means. So he's got a ton of stuff to go over. We're going to jump right in. I'm going to give us some housekeeping procedures, and then we'll be ready to go. So first off, this session is intended for a Kentucky audience. However, I know we have lots of people in here. I see lots of readers, lots of teachers, lots of students. So welcome to all. We will do all we can to provide everyone with an equitable opportunity to learn. If you are causing a disruption, you will be removed though, so please keep that in mind. Contact information is all on the screen in front of you. Give us a follow, reach out to us via email. If you have any follow-up questions after today, we'll be happy to get back to you. Your microphones will be off for the duration of the meeting, as well as your videos. Please leave those off. If you turn them on, you'll be removed. Please utilize that chat feature in the bottom right corner of your Zoom window. Dr. McGuffin and I will be monitoring the chat during the entire meeting. So if you have questions, if you're a teacher, student, regardless, please ask your questions and we will make sure we get those to Adam, who can answer for us. If you'd feel more comfortable shooting a message directly to Sherry or myself, you can do that as well, or you can pose a question to the entire group. But please, we value your participation and any questions you may have. Today's recording will be posted to kyap2020.com by the end of the day. You can also find all previous recordings as well as additional resources for both teachers and students. So please make sure you are checking that site out. New, just posted here at the beginning of this week, we are offering a mock exam reading and scoring session. So if you are interested in taking advantage of that, please go to that website and find more information. We have had AP exam readers develop questions based on their speculation as to how closely they can get it to what the AP exam might look like this year. And we will be doing a live scoring session for that as well. So you can have students take the test questions and then you can get firsthand responses about how to score those questions from the people who wrote those. So check out that website for more information. So at this point, I'm going to pause the recording for maybe 2-3 minutes. Make sure you've got today's handouts. Those can be found at the Bitly websites. And then also, if you can open up a second browser and just do a quick little sign in for me at this link. It's a very short 4 or 5 question Google form. And from there, we will go ahead and get started. So I'm pausing the recording and then giving you a few minutes here. Feel free to introduce yourself in the chat and any questions you have from there. I'm going to turn things over to our presenter for today, Mr. Adam Shrager. He can give you a little bit of information about him and his stats experience. He's coming to you from New Jersey, so he is very accustomed to this new environment that we're in, I imagine. So Adam, feel free to take it away.
Wow, you just gave me a tremendous amount of credit there, Aaron. But thank you, and I really appreciate it. I am from the wonderful state of New Jersey. Actually, I'm from New York. You will hear the New York accent, so I apologize. The longer I speak, the more it comes out. I am from Brooklyn, and you'll hear that. I've worked for a number of years with the wonderful teachers throughout Kentucky, through Advanced Kentucky, but I spend my days teaching at Hopewell Valley Central High School, which is in Pennington, New Jersey, right near where Washington crossed to Delaware. If that helps anybody, there's a picture of the school. So what we're gonna chat about today, and excuse me, just want to make sure I have my technology going here. What we're going to talk about today is we're going to talk a content review for Unit 7, which is tests for means. This is an overwhelming section of material to cover in an hour, to think about all the tests for means, as well as to think about T versus Z, and then how this material is going to be presented on this year's exam. So what we're going to do today is we're really just going to focus on content review. But let me give you guys a little pitch. Next Tuesday at this time, I'm back. Aaron and Sherry have invited me back for the free response strategies, how we can maximize our students' scores on the AP exams. And I've now been an AP reader and a table leader for a dozen years. And my first couple years teaching AP stats, that's the talk I wish I had gone to, because I had my students who knew what they were doing, but they weren't writing answers that would maximize their score and really demonstrate their depth of knowledge to an AP reader. So next week's session is all about strategies for free response. This week, we have so much content to cover in an hour that we are really just going to focus on content review. And I'm just going to throw in some commentary about what we know about the 2020 exam, most notably that students will not be asked to use a graphing calculator. And we suspect this means very, very nominal calculation. Okay, so here's what we're really going to be talking about today. The number one thing, of course, that we struggle with is when we read a question, what test or interval we're going to run. And every experienced teacher that I've chatted with, we're pretty sure this is going to be a question this year where the students will be presented with some data and then asked, okay, what test would you run if you were to analyze it? And then the students won't actually be asked to run the test. So today we're going to talk about one sample tests and one sample confidence intervals. Hopefully that should feel pretty comfortable. Start off with, kind of ease into a little review. We'll talk about match pairs tests, match pairs t-tests and confidence intervals, and we'll talk about two sample tests and confidence intervals. And of course, we have to chat about how we're going to distinguish between them. Once we've picked our test, then of course, we have to check conditions. We have to look for violations of conditions, and that could lend itself very nicely to a question this year. And then ultimately, using the results from a test, and again, we don't think students this year are going to be asked to calculate, let's see, a p-value, but we're absolutely sure that they're going to be asked to justify a claim given a p-value or given a confidence interval. What can we conclude? So that's really the focus of today. This is, it's about 6 weeks of class. I'm joking, but this is quite a few weeks of content, and we're going to cover it in an hour and hopefully have some fun. Let me encourage you, please ask questions, throw questions into the chat. Dr. McGuffin is going to be managing that chat, and she'll interrupt me. We've worked together for years. So let's make this as interactive as possible. Okay, so let's start off with something that hopefully should be pretty comfortable for everybody. And let's just warm up with a confidence interval for a single mean. So here's an example. We've sampled 40 batteries, and we find that they have an average life of 57 hours of use with a standard deviation of 12 hours. We wish to create a 95% confidence interval for the true mean lifetime of the batteries. Of course, we don't know the true mean. We can't sample every battery. We've only sampled 40 such batteries. Now, we can assume that the sampling distribution, that's the distribution of all possible X bars of size 40, is normal, and we assume that because of the central limit theorem. Okay, the distribution of these means, if we took sort of an infinite number of such samples, would be approximately normal. Why is the central limit theorem important here? Because I'm about to run a Z interval, which for most is the first test for means they're going to run. So here we go. Here's the calculation, and we are really not going to spend time in the next hour focused on these calculations. So the something like this. We're going to go through in a second, however, do you use a Z interval with means? So that was the question that just popped up. Phenomenal question. So a Z interval is for means or proportions, but T, which we'll get to in about 5 minutes, is only for means. So the T interval, the T statistic, which again is about 3 slides ahead of me, was actually invented to test beer at the Guinness Brewery, and it's the T is only for means, Z is for means or proportions. Here we have a sample size of 40, so you could use Z or T. I'm using Z just so we can all warm up, and because everybody knows that number 1.96. So we have our calculation. Again, we don't think the students this year are going to be asked to do this calculation. We end up with an interval of 53.28 and 60.72. So what does this mean? Okay, this means that we are 95% confident that the true mean, the parameter, the parameter that we can't possibly know, the true mean lifetime of these batteries is between 53.28 and 60.72. I can't read that entire comment, so if someone wants to read it out to me, that'd be great. Let me just finish this up here. We are 95% confident that the true mean is between these two values. Remember, this is a number we can't possibly know. We can't test every battery on the planet, but we're pretty confident that it's between these two numbers. Okay, so here is your calculation.
And Adam, the question,
yes.
Oh, sorry about that. The question was, do you think it's reasonable that they'll have to memorize? Yeah, that they'll be, students will have to memorize the star for 95%.
Okay, so the answer is phenomenal question, whoever asked that. The answer is absolutely, positively no. Now, I'm going to guess that most students are familiar with the with 1.96. However, what the test developers for this year have said is the expectation is that every student, I hope you can see what I'm about to show you, every student has in front of them a printout of the formulas and the tables for AP statistics. This would normally be tipped into the test book. So I have it printed on gold paper, and believe it or not, it's I don't do a lot of smart things, but the very last day of school for us, which was May 13th, I gave one of these to all my students, and I said, listen, take one of these home because who knows how we might need it. So what I'll do is I will take this formula sheet and these tables, and right before noon today, I'll make sure that the link, if anyone doesn't have them, that link is on the Advanced Kentucky site where these slides were. I'll throw it in there and also throw it into next week's material.
I'll add
phenomenal.
the College Board. Sorry, Adam. I'll add the link from the College Board for the reference sheet here in the chat box here in a second.
Perfect. Perfect. Yeah, put it there and let's put it up. The one thing they've made clear is they expect every single student to have that in front of them. So if a student know a critical value, the expectation is that they could look it up on the table if they don't know the 1.96. Okay. However, let's now take a look. Let's return to the confidence interval. Kyle, that was a great question. Thank you. I'm also impressed that I have my gold sheet of formulas right here. So I predicted that one. Aaron just posted the link in case you don't have it. You want to push that out to your kids right now. And if there's any students on this call, make sure you have that in front of you on May 22nd. Okay. When we look at a confidence interval, vocabulary this year is going to be very, very important. We know the majority of students have said they're going to be typing their answers. So that means we're going to be looking very carefully at vocabulary. So let's think about every confidence interval. Starts out with a statistic and then a plus minus sign times a critical value. In this case, it is a Z critical value times the standard deviation of statistics, with standard deviation of the statistic, which we know often goes by the fancy name standard error, and everything to the right of the plus minus sign in every confidence interval we talk about is our margin of error. Okay, so now let's take the same data and let's run a hypothesis test on that same question. Duracell claims that these batteries last for 60 hours. We think they're lying. We think that their sample about 40 batteries, we've tested them, and we found an average of 57 hours, standard deviation of 12 hours. So it's the same data. Difference is now that I'm going to look at this as one-tailed. And remember, in AP statistics, hypothesis tests can be one-tailed or two-tailed, but for AP stats, confidence intervals, we always think of them as being two-tailed. There is such a thing as a one-tailed confidence interval, but not in our course. So let's think this through. We found a mean of 57 for our sample of 40 batteries. 57 is less than 60. So what does this mean? This means that we have some evidence that Duracell is exaggerating, and that in fact the true lifetime of these batteries is not 60 hours. But is this really a meaningful difference, or is it attributable to random chance? That's the question here today. All right. Would we be surprised to find only one battery that lasted 57 hours? And the answer is, of course not. Right. That's just a variation in battery life. We've all used batteries, and we know they vary greatly in how long they last. But how about 40 batteries? How unlikely is that? Because remember, the law of large numbers tells us that when we start to take larger and larger sample sizes, those X bars, those sample means, start to look more and more like our parameters. So I told you this section, this unit 7 is just chock full of material, because we numbers, we get the central limit theorem, and then we have a whole series of different tests. So Duracell has made their claim. We have our null hypothesis that Duracell is telling the truth. The status quo, mean equals 60. Alternative hypothesis, the true mean is less than 60. Emphasize to your students that when you write a null and alternate hypothesis, you must have parameters. There must be mu's. One of the worst things that AP readers can see is an X bar in a null and an alternate hypothesis. That is, some students will write a happy face here or a heart, and as long as they define the happy face properly, it's fine. But what they can't do is put a statistic, put an X bar. The best thing, the safest thing for every student to do is to define that parameter. So in this case, mu is the true mean lifetime of these batteries. And of course, we can't know that mu, okay? Is the distribution of these X bars normal? Well, we can assume it is, because we have a sample size of 40, so the central limit theorem applies. We now have a z-score, which you can see that I've calculated for you. You could look that up on the normal curve table, or we could use normal CDF, and this would give us our p-value. Again, I'm going to say this a lot over the course of this hour. We don't think students are going to be asked to do this calculation this year. Okay. Instead, what they're going to do is they're going to be asked to check conditions and then to interpret that p-value. Let's take a look before we go further at the conditions, because this is vitally important. You probably want to make sure that the students have the conditions in front of them and that they're practicing applying those over the course of the next month. So the first condition for all the tested intervals we're going to look at is, was the data drawn from a simple random sample? In this case, we had a simple random sample of batteries. I did want to mention that if the data came from an experiment, this was not an experiment, there was no treatment imposed, but if it came from an experiment, the correct condition is that we had a random selection or a random assignment, if you will, of treatment and control. One of the little tricks, one of the AP tricks, I don't love saying this, but I'd like your students to do well, is if a student writes SRS, and the question is about an experiment, technically that's wrong. But on the AP, if the student writes random check, they would actually get credit, because the random could apply to random assignment for an experiment, or it could apply to SRS. Okay, so we have the random condition. We know the 10% condition. Clearly, my sample of 40 batteries is fewer 10% of all the batteries that are produced. We're not going to get into that one too deeply. And finally, and here's the big dog. I've answered this question from my students alone about 10 times in the last week, is Z versus T. Is the population of means normally distributed? Well, we have a large sample size, so the central limit theorem applies. If we didn't have a large sample size, and we're going to use 30 for large, then we'd have to look for skew and outliers. So let's take a pause and let's think about when we should use Z, when we should use T. This could be a very nice question, and this just ties teachers and students in knots. I was actually yesterday talking to a teacher in Ohio, and we had this conversation for about half an hour. He was very, very confused. So if you're new to teaching AP Stats, please don't be shy to ask questions about what I've just posted here. When do we use Z? If the question says the data is normally distributed, then we use Z-scores. There is only one Z distributed. And if it says normal, we're good to go. That's very rare in the real world. It's not rare in an AP Stats textbook, but on an AP exam, telling you the data is normal just isn't that common. If we have a large sample size, it's not really about the sample size. It's really about the central limit theorem. Then Z would apply. What's more common? Small sample size, and we don't know sigma. Knowing sigma is very, very, very rare. There's very few circumstances in the real world where we know the true population standard deviation. Since we don't know sigma, we have to use S, and we have a small sample size. I mean, the central limit theorem doesn't apply. We can't assume the distribution of sample means is normal. Therefore, we're going to use a T distribution, and we have to check for skew and outliers. All right, so let's move forward. Okay, we're going to check conditions for every test and for every interval. That would be a nice question this year. If you choose to use T, we'll have to note the degrees of freedom. I cannot imagine when we get into 2 sample tests, they'll ask the students to come up with the degrees of freedom this year, because that would require the calculator. But certainly for a 1 sample test, n-1 degrees of freedom, that's perfectly reasonable. If the student is given the data, which is very common in a T distribution question, then we usually ask them to graph it to check for skew and outliers. I have my students do box and whisker plots, but some teachers do histograms. Lots of graphical displays work, because Trevor Packer at the College Board announced last Tuesday that the majority of students have said they're going to do this exam on their Chromebooks in Google Docs. Most experienced AP Stat teachers and readers sincerely doubt, I can't promise anything, but we doubt that students are going to be asked to draw anything this year. You're going to be asked to interpret graphical displays, but we don't think students are going to draw. I know that he said that students can draw pictures and take pictures with their phone and upload those pictures, but how about if a kid doesn't have that technology? If all the kid has is a Chromebook, that kid has to be on a level playing field. And let's face it, it's quite tricky to draw a picture in Google Docs on a Chromebook. So you can attribute this guess to me in case, God forbid, I'm wrong. But we really don't think this year, and this year alone, students are going to be asked to draw graphical displays. Okay, please throw questions in the chat, or I'm just going to plow forward. Okay, so another question. And now a little hint here, this is going to be a T. In a sample of 17 WKU, Go Hilltoppers undergraduate students, we find they spend an average of 52.1 hours per month on the internet, with a standard deviation of 28.4 hours. The Nielsen company reported that US residents 18 to 24 spend an average of 35.5 hours per month on the internet, pandemic notwithstanding, of course. So let's calculate a 95% confidence interval for the true mean amount of time spent on the internet by WKU undergraduates. And do we have convincing evidence that WKU undergraduates are different, from typical US residents of this age? And then we're going to do a hypothesis test. We observe, of course, that my sample of 17 students spends 52.1 hours per month on the internet. And typically, people of this age spend 35.5 hours. So we have some evidence that WKU students spend more time on the internet, but is it a statistically significant? Okay, so what I've done now is I've calculated the confidence interval. And again, to repeat myself, we know the students are not being asked to touch the calculators, but there's gonna be questions on inference. Typically, it's 40% of an AP exam. So it's very reasonable to believe that students will be given the interval and asked to interpret it. So that's the big deal here. I've calculated this interval for you. We are 95% confident the mean number of hours spent on the internet every month by WKU students is within the interval of 37.498 and 66.7. Therefore, this would be a wonderful statement for students to have to write this year. We have convincing evidence that WKU students are different from typical US residents age 18-24 with regard to internet usage, since 35.5 is not in the interval. 35.5 is not a plausible value for the true number of hours spent on the internet by Western Kentucky undergraduates. Please look at the language there, plausible value. AP readers, we call this a wiggle word, right? If a student says we have therefore proven that Western Kentucky students are different, that's wrong. We can't prove anything. Heck, we only have a sample of 17 students. But what we're saying is it's implausible that they are the same, because the parameter 35.5 is not in the interval we've created for Western Kentucky students. Hey, you're looking at that interval and you're saying, wow, that's quite a wide interval. Of course it is, because we only surveyed 17 students and we had a reasonably high standard deviation. How could we narrow the survey more kids? Okay, be careful. Make sure your students are putting in these wiggle words like plausible, and they never using the word prove. All right, good. Here's the hypothesis test on the same data. This is going to be a t-test. Again, we have a small sample size. We can't assume the central limit theorem applies here. We will assume, though, that my conditions are met since I never gave you the data. My null hypothesis is that the Western Kentucky students have the same mean as the rest of the country, mu equals 35.5. Alternative hypothesis, mu is not equal to 35.5. I calculated a t-statistic and a p-value. Again, we believe this year those will be given to the students, but now let's interpret them. Since p is less than my alpha of 0.05, we reject the null, we accept the alternate, and we conclude that the true mean internet usage by these undergrads is not equal to 35.5, okay? If you're asked to interpret the p-value, this is one of the most challenging questions that we ask AP students. I also teach at 2 different universities, and I can tell you with absolutely no question, this is the hardest question I ask university students to interpret a p-value. If the null hypothesis is true, then the true mean of these Western Kentucky undergraduates is the same for that of the country. So if the null is true and Western Kentucky students are the same as the country, then the probability that we would observe a result this extreme or more so is about 2.8%. And that is low enough for us to be convinced that we should reject the null. Okay, so what we're going to do is we're going to now jump into 2 sample tests. Let me take a 30-second breather. We've talked now about a z-test, a z-interval, a t-test, and a t-interval. So now we're going to apply all that to 2 samples, looking at when they are independent and when they're not independent. But let me breathe. Are there questions? Dr. McGuffin, has anything popped up in the chat? I don't have it up on my screen. And I know Bob Lachelle said something. For those of you that missed it, Bob, the presentation 2 weeks ago.
One thing Bob pointed out here, it said maybe a point for the end of the webinar, but the difference between Z and T, while the difference for Z and T for means is an interesting stats discussion, and then the belief is that inference for means using Z is no longer eligible for content based on the CED.
Okay. Okay, yeah. I mean, most of the textbooks sort of start with that z-test and then plow forward to T, but that's exactly correct. And thank you, Bob. Bob and I go way back. Students won't be running a z-test. They won't be interpreting a z-test this year. We're going to stick almost exclusively with T. But of course, you know, it's frustrating because they start the course learning the normal curve and learning 1.96. And to Bob's point, that Z-test is no longer part of the CED. Any questions on what we just presented? Bob, thank you for that. All right, so let's plow forward. I hope this is sort of fun, not too painful. We're going to talk about match pairs tests, and we're going to talk about two sample tests, all tests for means. So we have to distinguish the two. This is a favorite AP question where the student is presented some data and they have to first come up with what test to run. So are they going to look at match samples, identical twins? Pretty common in biology questions and psychology questions. And the strategy here would be to find the differences, let's say, between the twins, and run a test on the mean of the differences. And then versus a two sample test, which is for two independent random samples. And there's a number of review sessions that are floating around out there where they periodically forget the word independent. This is a vital word. If we're going to run a two sample test, whether it's two proportions or two means, if it's going to be a two sample test, the two samples must be independent of one another. That word is vital. And we're going to run a test on the difference in the means. I don't ever expect my students to get this grammar correct, a t-test on the mean of the differences or a test on the difference in means, but it's actually a pretty vital distinction. Okay, so we'll start off and we'll look at a match pairs test. Here, sometimes called a paired sample test. We can look at test scores before and after, weight before and after, identical twins, one gets the control and one gets the treatment, the same plant, the same dogs from the same litter, but we are matching them. The two samples are not independent of one another. And the strategy will be that we're going to run a t-test on the differences. Null hypothesis. So I always have my students write it as mu diff equals 0, and the alternative hypothesis as mu diff is not equals to 0, or greater than or less than. I have them do this so that for two reasons. Reason number one is that they really distinguish match pairs from two sample, and the AP loves both of them, okay? The second reason I have them do this, which is less relevant for 2020, is when they enter the match pairs on the calculator, they're entering it as a t-test, whereas when they're entering two sample on the calculator, they have to enter in the two different means. So this is closer to what would go into the calculator, but that's probably not as relevant this year. So we're going to run a t-test on the differences. This slide would run you through the calculator methodology, but I'm going to go right over it because we know they're not doing that this year, and that's what I've written here in red. You will not need to enter this data and run a hypothesis test on the calculator for this year's exam. Okay, so what are we going to do for the interval is we're going to find, we're going to look at the difference, and we're going to find the mean of the differences and create an interval around that mean. The question we're going to ask, this would be a wonderful question for this year, is 0 in the interval? Because we are 95% confident that the true difference is within the interval. And it's actually, this should say the true mean of the differences. I apologize, I screwed up my own grammar. So there's a couple of small typos, and I will be uploading the new version of this presentation at 11 o'clock this morning, Eastern time. Okay, we're going to look at whether or not 0 is in the interval. That is the big question with the match pairs T interval. Okay, we will look at our conditions, and again, we have to look at the differences. The question is, are the differences normally distributed? No skew and no outliers in our match pairs t-test. Very common to have a nice small sample size here where we have the paired data. So here's an example. So let's all take a breath and let's think through this example and see what's going on here. My students love this example. Feel free to give this to them. They probably haven't seen it before. Does too much sleep impair intellectual performance? Researchers examined this commonly held belief by comparing the performance of subjects on the mornings following A, 2 nights normal sleep, and B, 2 nights extended sleep. And my teenagers love talking about how much sleep they got or how much sleep they didn't get. The order of these 2 treatments was determined randomly. In the morning, they were given a number of tests of ability to think quickly and clearly. One test was for vigilance, where the lower score, the more vigilant. So let's think this through. Lower score means you are more vigilant. And then the question is, do students who get extended sleep, are they less vigilant? Which is to say, we're sort of asking this question, do the extended sleep have a higher vigilance score, which would imply that they are less vigilant? I know that seems a little bit backwards, but I think it's important to present this to your students. We know that the AP, they love questions about, track meets and swimming, and these are contests where lower scores are the winners. So here's an example where the lower score is more vigilant. And as we can just take a quick peek, you can usually take a look at the data. I force my students to stop and look at the data before they touch their calculator and tell me if they observe anything. And sure enough, person C, person E, person F, person G, H, and I all have this higher vigilance score, implying they are less alert. 2 students, two of the subjects had lower scores after getting more sleep, and a couple had the same. So we can sort of have a conversation of whether or not we think the difference matters before we've even done any calculation, okay? So let me emphasize that I don't think they're calculating anything this year. What I do think is going to happen is that they're going to be given the results. So can you imagine a question this year where first the student is asked what test you would run? That's a question. And then the student is given these statistics, given a t-score, given a p-value, and asked to justify a conclusion. Just so everyone's clear, I'm gonna throw something out here. What we've been told is there's this 25-minute section and a 15-minute section. The 25-minute section is going to be worth roughly 55 points, and the 15-minute section is going to be roughly 45%. So it's going to be a 55% part and a 45% part. So there's been a number of authors that have put webinars out there that have hypothesized what this might mean. Is question number 1 is going to have 5 parts, and question number 2 is going to have 4 parts. I don't know if that's true, but that would lend itself very nicely to sort of this 55-45 breakdown. And why is that important to us right now is because what we're projecting is questions with multiple parts. So one part, what tests would you run? And then one part more challenging, which is let's interpret the result. What can we conclude from this test? What might this p-value mean? So here we go. We're given a p-value, and if we assume an alpha 0.05, p is greater than alpha, we cannot reject a null, and we cannot conclude, therefore, that extended sleep leads to less average vigilance. So when they write these conclusions about tests for means, we would really like them to get the word average or mean into their conclusion. Okay, we want to know that they know what they're talking about. It's not leads to less vigilance, it leads to less vigilance on average. Okay, questions there on match pairs? I don't see anything popping up. So let's talk about the 2-sample test. So the 2-sample test is sort of the big dog, right? Very common. We look at 2 independent random samples. My timing looks good, by the way. I just checked. Here we have data that is not paired. So very common. Men versus women. Democrats versus Republicans. Not so much on the AP. Freshmen versus seniors. Control versus treatment. 2 groups that don't interact with one or the other. I just saw a question pop up. Where does type 1 and type 2 appear? Phenomenal question. Sorry, I missed the name of the person that asked that question. Great question. So type 1 versus type 2 is not in unit 7, but I'm going to, in next week's, when we talk about free response strategies, we're going to talk quite a bit about how questions might look with type 1 versus type 2, because that is a dream question for this year, because it's all about writing the consequences for type 1 versus. So it's not a particularly, in terms of the content for this week, it doesn't appear in Unit 7. I know there's a couple of experienced readers with me here. Is that Unit 5 or Unit 6, where type 1 and type 2 first shows up? Bob or Forrest or Matt, maybe Aaron or Sherry, whatever. I can find that answer for you. So we're not going to review type 1 type 2 here, but next week, I promise I have a type 1 type 2 question already queued up, because it is a dream question for the 2020 exam. So great question. Okay, so let's plow forward here. We're going to look at 2 independent samples, men versus women, Democrats and Republicans, freshmen versus seniors. And what we're going to do is we're going to look for the difference now in the means. So remember, that means subtract. Okay, Unit 6, Bob says. Thank you very much, Bob. So if you go back to last week's presentation from Reva Sloan, she was type 1, type 2. Bob, I sincerely appreciate that. But I'm going to be we're going to look at a type 1, type 2 question next week, and exactly what the readers and what we believe thank you, Dr. McGuffin, what we believe that the readers and the rubric will look for this year. But let's all think about this. If a student is taking the entire exam and they're typing it on their Chromebook in Google Docs, and we heard that news 1 week ago today, that's what the AP expects the majority of students to be doing, then we have to think about questions where the answers are going to be typed. And a dream question is to name the error, interpret the error, and give the consequences. So I'm sorry I missed the name of the person that asked that question. It flew by on my chat, but great question. And I absolutely promise you next week, we're going to do one. Next week, I'm going to post a series of questions and a separate document with an answer key. So we're going to go through the questions in this session, and then you'll be able to use the document however you like with your students. Great. Thank you, Dr. McGuffin. She's saying that last week's session from Reva Sloan had a bit on type 1, type 2 errors. So here, we're looking at a 2-sample test. We want to look at difference in means. Remember, that means subtract, right? If I tell you that, seniors have an average of $150 in their bank accounts, and freshmen have an average of $30 in their bank accounts, it's reasonable to say that the difference in their averages is $120. Why can we say that? Because means subtract. But of course, standard deviations do not subtract. And we know that from Unit 5. We know that from probability. So what do we have to do? We have to find the variances and add them up and take the square root. And thankfully, we do not believe the student's going to be asked to do that this year. So when we look at a 2-sample test, I usually write it as mu1 and mu2. And the alternative hypothesis would be mu1 is not equal to mu2. It could be less than, it could be greater than if we're running a hypothesis test. Remember, in the AP world, if we're running a confidence interval, it's always going to be two-tailed, okay? And you're going to have to define those parameters. So as we know, mu1 is the true mean of whatever your first group is. And of course, mu2 is the very famous Pokemon. I figured we could use a laugh right now. This is literally my students' favorite slide of the year when I post up the famous Pokemon called Mewtwo. All right, enough of that. mu1 is the true mean of the first group. Mu2 is the true mean of the second group. The calculation for T, this is a very hairy calculation. We do not believe that students will be asked to calculate it. However, remember, it's on the formula packet. You now have that link. Aaron Timmons put it up in the chat, and I'm going to put it up in the shared documents when we're all done here. Although this is a very hairy looking calculation, and I don't believe students are going to have to plug into it, what we're really looking at here is what's in the numerator is the difference in the sample means. That's our statistic. What's in the denominator? It's the standard deviation squared over n. Well, that's just s over root n squared. And we know that. We know the standard deviation of a sample mean squared plus the standard deviation of the other sample mean squared, because in order to find the difference in the standard deviations, we can't do that. So we have to sum the variances. That's all this is, the standard deviation squared, and find the square root. Okay, that's very hairy. And again, I put it in big red letters. We don't believe that the students will be calculating this either by hand or on their calculators just for 2020. So in a typical year, we clearly can't gloss over the math for a 2-sample t-test, but this year I think we can be a little bit gentler. And what we want to do, again, sorry to repeat myself, but we really want to do is we want to emphasize the conclusion and what we can justify from that conclusion. So here's a quick example. And I want to make a couple points about this data that hopefully are not too intense. The question here is the effectiveness of intensive tutoring different than the effectiveness of paced tutoring? And the students will be asked to run a hypothesis test to investigate. Now, again, this year they won't be asked to run it, but they might ask, what test would you run? And then the students will be given some statistics and asked to interpret it. But the first thing I would ask kids is, how do we know, looking at these students that got intensive tutoring and these students that got paced tutoring, we can see that it's a test for means. That's all we're talking about today, because we're given means. There's no proportions here. And I probably should have started out 45 minutes ago with we're talking about means. And the very first thing that kids need to do when they read a question is ask themselves, is this question about means or is this question about proportions? Clearly, this one is about means. So the big question now is, how do we know this isn't match pairs and this is 2-sample? And we can all kind of look at it, and so it's obvious. It has to be able to articulate. So what's the number one answer? How do we know it's not a match pairs and it is a sample test? Answer number one is that it's pretty reasonable to assume that the performance of these two groups are independent of one another. One group of kids randomly selected. I know they were randomly selected because it says the conditions for inference have been met. One group of kids was sitting in a room getting intensive tutoring a few days before the exam. The other group of kids was sitting in a different room getting some sort of paced tutoring over a series of weeks before an exam. And they're independent from one another. They're getting different types of training. It's unreasonable to believe that they interacted, and it says the conditions for inference have been met. Therefore, we can assume that two groups are independent. That makes this a 2-sample test. There's a second way we know this can't possibly be match pairs, and this is not a terrible answer. How do we know possibly be a match pairs test? And the answer is we have 2 different sample sizes. So we have 2 different sample sizes. The real world of 2-sample tests all the time. This frustrates my students to no end. Here they're 2 different samples. They don't, it seems sort of unbalanced. So what I tell them is, maybe both groups out with 15 kids, and then some kids just dropped out of the study. They stopped showing up to tutoring, so we had to drop them from the data, and we ended up with 12 and with 10. So this is not match pairs. This is going to be a 2-sample test for means, and it is a t-test. We know it's a t-test because of sample sizes, besides what Bob Lachelle earlier in the chat. There's not going to sample Z because it's the CED this year. Okay, so we will run a hypothesis test on the data, and we could also be asked to run a confidence interval on the data. Remember, here is the effectiveness of tutoring different than the effectiveness of tutoring? So that way, my own question, by wording it this way, opened up the door to either run a hypothesis test or a confidence interval. So what would the confidence interval look like? So here we have this crazy, messy equation, but if we think all the way back to 45 minutes ago, it's still the statistic. Here, the statistic is the difference in the means. That is our statistic, also called our point estimate. Point estimate is a great term for your kids, and we realized in 2020 that the wording, what they write, is going to be just so important. So the point estimate, here's what I like to say about point estimate. Point estimate is, if I held a gun to your head and I said, what's the difference between intensive and PACE tutoring, what would you guess? And your best guess is the difference between these two numbers. Looks like about 3.5 points is the difference between intensive and PACE tutoring. What do we know about 3.5 points? Probably wrong, probably close. That's what a point estimate is. And that's the value, the statistic to the left of the plus minus sign in every confidence interval, whether it's for a single mean, two sample, match pairs, confidence intervals for proportions, and the kind of confidence intervals that we're not talking about this year, like those for slope. So we have our statistic, plus and minus, our critical value, now it is a t statistic, times the standard deviation of the difference in sample means. Because that's such a mouthful, we often refer to this just as the standard error. Again, there is no way kids are plugging into this year, and we don't believe they're doing it on the calculator, but I think it's very reasonable that they're going to be asked to an interval and then asked the question, is 0 in the interval? So I've done it for you, and all the answers to all these questions are within the body of this presentation. So we don't think we're going to calculate it, but asking a student to interpret a 2-sample test or a 2-sample interval would be very, very, very reasonable, especially when you consider that we believe, and it should be consistent, about 40% of the test, maybe a hair less this year, but about 40% of this test should be focused on inference. And without chi-square and without the Lin-Reg t-test, they got to ask something, so they're going to ask about means and proportions. Okay, so here we go. Hypothesis, mu1 equals to mu2. Alternate hypothesis, mu1 is not equal to mu2. We define our parameters. Mu1 is the true mean test scores of students that got intensive tutoring. Mu2 is the true mean test scores of students that receive PACE tutoring. I calculated my t statistic, my p-value, and my degrees of freedom. That came right off my TI-84, which we know they're not doing this year, but it's very reasonable that students are handed this data, and then we are maybe asked to interpret a conclusion. What result can we justify? Are they different? And again, let's go back. Do we have some evidence that intensive tutoring and PACE tutoring are different? Of course we do, because the means are different, the sample means. But are we convinced that the means are different? And the answer is no. Since P is greater than alpha, really any reasonable alpha, since I haven't given you an alpha here, we do not reject the null, and we cannot conclude that intensive tutoring and PACE tutoring have different true average effectivenesses. Get your students in their conclusions to reference the parameter. The worst thing the kid can say down here is sample. We want them to talk about the true mean, the population mean, or the mu. So we like it when they say it here, when they define mu1 and mu2, and we like it when they say it in this final conclusion, when they interpret the p-value, which we're pretty sure they're going to be given this year. But how do you have an AP test without a p-value? So they're going to get a p-value, even though it's only 2 questions. They're going to get a p-value. At the very least, they're going to get a confidence interval, and they're going to be asked to interpret it. I'm friendly with a group of AP teachers, and they all, for some reason, are convinced that the kids are getting a confidence interval this year. So let's look at this confidence interval. Here is my 95% 2-sample T confidence interval. Again, I generated this on my calculator. We are 95% confident that the true difference in the mean effectiveness, there's that parameter, the true difference in the means of effectiveness between these types of tutoring is within this interval. Can we conclude, therefore, that they are different? And the answer is no. Since 0 is in the interval, we cannot conclude that the average effectiveness of these types of tutoring are different. It is plausible they are the same. If a kid says, therefore we conclude they're the same, they just accepted the null. And we know that is a big, big, big no-no. We never accept a hoe in AP Stats. So what we want to do is we want to fail to reject it. And we can say it is plausible that they are the same. That's what's meant by 0 is in the interval. But without that wiggle word, it's very dangerous. I want to point out one final thing about this slide. Correct. Thank you very much, Dr. McGuffin. We fail to reject the null. That means the null is plausible. Please review with your students. We don't want any stronger word than plausible. The worst thing a kid can say, and we've seen this 1,000 times, where a kid writes everything correct, and then at the very end, they say, AP readers, we call this shooting themselves in their foot. The very end, they say, therefore, the means are the same, or therefore, the tutoring strategies are the same. They've just crushed what was otherwise a beautiful answer. So we want to be very, very careful that they don't say they're the same. They don't accept the null hypothesis. That is absolute crime in AP Stat. I want to make one more point here. We have a conclusion from a hypothesis test. P is greater than alpha. We do not reject the null. We cannot conclude that the two types of tutoring are different in terms of average effectiveness. And then we have a confidence interval. 0 is in the interval. We cannot conclude that the two types of tutoring are different. If we have a hypothesis test and a confidence interval on the same material, the answers should be consistent with one another. Now, anecdotally, this is a very popular multiple choice question on the AP. Historically, we know there's no multiple choice this year, but what they will do is they will give you a p-value in a multiple choice question and then say, you know, what do we know about the confidence interval? And what they're really asking the student to know is that the conclusions for the two sample tests should be consistent. Two tailed test and the confidence interval, we should get instant results. Obviously, that's not a choice question this year, but it could very reasonably show up in this way, where we're looking for the consistency between the two answers, whether you're running a confidence interval or a hypothesis test. I think that would be actually a really nice question this year. So we do have to look at conditions before we wrap up. The conditions for the two sample test, I promise, I know it's 11 o'clock, 4 minutes tops, and we're done. And I will stay on and we can answer any questions that pop up in the chat. First of all, independent simple random samples. Please be very, very, very careful. In the past, AP readers have been told to ding students who leave off the word independent for two sample tests. And there's some review materials out there that are a little loosey-goosey with the word independent. It's a very important word for two sample tests, for means or for proportions. We still have the 10% condition, and then each of the individual populations must be normally distributed. Neither can have extreme skew, and neither can have outliers. Again, I'm not quite sure how they would have students test for that this year, but in a typical year, this is a bit onerous for students to do. So finally, let's think about, when we're thinking about tests for means, let's think about tips and strategies. So this is just about Unit 7. And again, next Tuesday at 10 o'clock in the morning, I've been invited back, assuming Mr. Timmons and Dr. McGuffin want me back after this. And we're going to talk about free response strategies for the entire exam. And I'm going to really try to give it to you from the perspective of a reader and perspective of what we think we're seeing this year, really minimizing calculations and really thinking about the wording that our students give us. So this is my last slide. Here's the big takeaways. First of all, we really don't want to focus on calculator commands. We have roughly 1 month until the exam. Actually, I correct that. We have exactly 1 month until the exam. 1 month from today, we really don't want to focus on button pushing. You know, the joke when students walk into AP statistics the first day is that we're in AP calculator. This year, that's out the window, okay? Be absolutely certain that the students may be asked to name a test. They need to know the distinction between match pairs and two sample. First, is it means or proportions? That's usually pretty easy. I found them that they're really good at that. And especially this year, there's no cotter. So it's really a question of means versus proportions. But then if there's two distinct samples, are they independent or have they been matched? We could also imagine, by the way, and we'll chat about this a little more next week. Remember, matched pairs is a special form of blocking. So it's blocking by twos. So we know we're only going to have 2 questions this year, and the questions will be comprised of multiple units from the course. So imagine a really lovely match pairs t-test that also has a little bit of that blocking, that experimental design. Okay, so that's not for today, but that's going to come up next week. We're going to look at a question that's going to look like that. Okay, we want to make sure that the students understand the violations of the conditions for a t-test, notably extreme skew and outliers. Let me make a final point about that, okay? With a t-test, we don't know it's normal. Think back to the 17 Western Kentucky University students, those 17 Hilltoppers. We have no extreme skew and no outliers. You can't prove normality from a sample of 17. It's possible. So what I like to say is, and again, this will be part of next week as we talk about strategies, what I like to say is we have no evidence of non-normality. So we proceed. Let me say that again. We can't prove normality from a small sample, but what we can say is no evidence of non-normality. So we proceed with the t-test, which is relatively a conservative test, okay? All the energy, all my students, I have 95 AP students this year, and all I want them doing is interpreting. I want them writing for the next month. You know, it's crazy. I've never taught a month of statistics without a calculator, but that's literally my goal as I teach virtually for the next month is let's interpret these results. Let's interpret those type 1 and type 2 errors. Let's think about what tests to run. And the only calculator really should be some very simple calculations with probability. And I'm not going to chat about that today. That'll also be part of next week as we look at the types of probability problems that may show up this year. So thank you for everybody's time. I'm not going anywhere. Aaron, have I missed anything? Or Dr. Have I missed anything tremendous that I should have thrown out there? Or did I misspeak horribly?
I think you did a very good job.
Thank you. I wasn't fishing for compliments. Yeah, go ahead.
One question that kind of came up during a private message to me, and this is just something we can kind of put out there, and if there are other experienced AP teachers and with Mr. Shrager here as well, just if you some teachers that may be limited on the amount of content that they can actually assign to their students, if a teacher wanted to get the most bang for their buck and just a limited amount of content, just suggestions of what they could include to get the most bang for the buck in the next month.
So I am struggling. You are preaching to the choir, whoever asked that question. In a typical week, I would have seen my kids 4 days out of 5, and then I would be assigning them. I mean, it's April 22nd. The AP is around the corner. I'd be assigning them, you know, at least a question every night. I am now limited to 1 hour every 2 days, and I'm being asked not to exceed that. And not to make anybody sad, but I am in northern New Jersey, and we're sort of a hotbed for COVID, and we have families dealing with very, very serious matters now that are much bigger than AP tests. So I am struggling with what I'm going to do with my very, very limited time. So what I've been doing is looking at AP questions that are all about interpretation. They're all about words, and then assigning those. And then I'm giving the students the resources, the Advanced Kentucky videos and the College Board videos and a few others that are out there, so that they can review on their own if they have that bandwidth, you know, that time and that energy. But in terms of what I have them doing, is I have them doing as much interpretation as possible, reviewing things like independence from probability, things where I think are reasonable questions this year. It's all about writing. And the last assignment that I gave them last week, and I'll be happy to share this out. I did this actually with Aaron at a fall forum a number of years ago, was an assignment where I just have the students read 10 hypothesis tests and write what test they would run. I don't make them run the test. I don't make them touch a calculator. It's what test you would run, what's the null, and what's the alternate. And they were able to essentially do the 10 of them in half an hour. And then I was able to go over them. And I would say that since the lockdown, which for me started March 13th, I'd say that's probably been the most valuable hour that I've had with these kids. If anybody would like that assignment, I'll be happy to share it out. It's not specific to Unit 7, but it's an assignment of dozens of hypothesis tests, and I simply push it out for them. What test and what's the null and the alternate? No calculation, no interpretation, what test to run. And my money says that's on this year's AP. I hope that's helpful.
And Adam, if you want, you can just upload that to the main stats folder that you have access to. So those of you out there that would like that, you can just look in there where you would access your handouts anyways, and you can find it there.
Yeah, I would honestly say, being very limited with the time I have with my kids, that is the best hour I've seen in the last month. What test would they run?
All right, are there any other questions? I'm going to share a wrap-up screen here. All right, so again, Sherry, Adam, if you see any chat questions, feel free to interrupt me. But thanks for joining us today, Adam. Adam, you did an incredible job. I think you've covered a large amount of material in a very short amount of time. So
you assigned it, Aaron. I did my best to try to get through every page.
We can go back and watch our half speed.
Okay.
But if you have follow-up questions for Adam, Sherry, or myself, feel free to send us an email. You can find our contact information on the screen in front of you. Handouts, again, the extra resource that Adam talked about, as well as updated materials from today's presentation, can all be found there at kyap2020.com or the bit.ly link. Today's recording will also be posted there as well. Adam alluded to already, next week he'll be back. So he'll be going over free response strategies, mixed review. And then also we have added one additional review session on May 21st. So that's the day before the AP exam. Bob Lachelle will be back with us to go over those. Also, if you want to partake or participate in our mock reading, feel free to look that information up on the KYAP 2020 website also. But if you all have any other question, or if there are no other questions, then we will go ahead and sign off. Adam, sure if you can hang out for a second for a quick debrief. But other than that, if there's no other questions, we will sign off. Hopefully we will see you back here same time next week.
Thank you, everybody.
All right. See you all later.